So now we have understood like what is cumulative frequency distribution. Now we'll see one problem on cumulative frequency distribution. Then we'll move forward. Let's first write down the example. Sometimes like we have seen that how to convert the frequency distribution table into the cumulative frequency distribution table. But there are some problems like in which sometimes the cumulative frequency distribution table will be converted to the frequency distribution table. So now we'll see how to convert the cumulative frequency distribution table into frequency distribution table. So first write down the example is a cumulative frequency distribution table is given below. Convert this into a frequency distribution table. So there is a cumulative frequency distribution table that should be given. First we make the cumulative frequency distribution table, and accordingly we'll see how to convert it into the frequency distribution table. So these are the marks and accordingly the number of students. Marks and number of students. So marks below 45, number of students 0. Marks below 60, number of students 8. Marks below 75, number of students 23. Marks below 90, so number of students 48. Marks below 105, number of students 85, and marks below 120, number of students is 116. So here is the cumulative frequency distribution table. Below means is actually a less than table. So instead of less than we are using below. So that is less than 45, less than 60, less than 75, less than 90, less than 105 and less than 120, and accordingly number of students are given. So this is a cumulative frequency distribution table. So now we'll see how to convert it into a frequency distribution table. So as we know in a frequency distribution table, as we know that the class size should be, it is very important to keep the class size same. It's not necessary, but definitely we want to keep the class size same, and accordingly we'll make the table. So as you are seeing here that the marks given are below 45, below 60, below 75. So the numbers that are using, that is 45, 60, 75, if you see the difference between these numbers is same, that is 15. So it means accordingly we'll make the class size. So accordingly we'll make the class size as 15. So first thing will be class interval, and accordingly frequency or number of students. So class size, first class size will be, it is not necessary that always you have to start the class size from 0. So initially it is given that is below 45. So definitely as below 45 is given, so definitely in that cases we definitely need to start from 0. But number of students below 45 is 0. So it is not necessary to start from 0. So directly we can start from 45. So accordingly our first class will be 45 to 60, because below 45 there are no students. So it is not necessary to take the class interval below 45. So but suppose if there were students below 45, so definitely we need to take the class below 45. That is, we generally take the class in that case from 0 to 45. We will not divide that class into the class size of 15. That is, suppose we need to take the class intervals below 45 then in this problem. So then accordingly we will not take the class size from 0 to 15, 15 to 30 and 30 to 45, because we don't know how many students are there which are between 0 to 15, 15 to 20, 30 and 30 to 45. So in that case, if there are students below 45, so definitely we will take the class from 0 to 45. But in that case, our class size will differ. That's okay. Sometimes it may be the possibility that class size will differ. But in this case, as there are no students below 45, so we will not take the class from 0 to 45. We will definitely, in that case, we will start from 45 to 60, then again from 60 to 75, then 75 to 90, then 90 to 105, and then 105 to 120. Now we need to write down the number of students. So between 45 to 60, if we'll see that there are 8 students below 60. So definitely they will come in 45 to 60 only, because as there are no students below 45, so definitely the 8 students which are there below 60 will definitely come between 45 to 60. So number of students here are 8. Now below 75. So if we need to take the number of students, below 75, then what we need to do? We need to take the number of students below 70, between 60 to 75, and number of students below 75 are given, that is 23. So if we need to take the number of students between 60 to 75, what we need to do? We need to subtract those students which are below 60. Below 75 actually covers all students which are below 45 and below 60. So definitely we need to subtract the students which are below 60 from the students which are below 75. Then we'll get the number of students between 60 to 75. So that it means number of students, if you need to find out number of students in the class interval 60 to 75, what we need to do? We need to take the number of students below 75 and we need to subtract the number of students below 60. So it means 23 minus 8. So we'll get the number of students between 60 to 75, that is 15. So between 60 to 75 is 15. In the same way, what we need to do in case of 75 to 90, as it is given that number of students below 90 are 48. So it means it includes all students which are below 45 also, below 60 also, and below 75 also. So below 75, as we know that there are 23 students, and below 90 are 48 students. So it means below 90 consists of all, those students also which are below 75. So definitely if we need to find out the number of students between 75 to 90, then accordingly we need to subtract the number of students below 90, we need to subtract from this the number of students below 75. So again, if we need to find out between 75 to 90, what we need to do? We need to do 48 minus 23, that is 25. Then again in this case, between 90 to 105, what we need to do? We need to subtract 85 minus 48. So accordingly we will get 37. And to find out the number of students between 105 to 120, what we need to do? We need to subtract the students below 120 and the below 105. So accordingly we will get the number of students between 105 to 120, that is 31. So now this table is actually a frequency distribution table, because it consists of class intervals with the number of students. So this is now the proper frequency distribution table, which we have converted from cumulative frequency distribution table to the frequency distribution table. So in this way, like we can convert the data into tabular form. So these are the methods we have seen, that is frequency distribution table, cumulative frequency distribution table. So these are the methods to convert the data into the tabular form. Now we'll see how to convert the data into the graphical form or the pictorial form. So we'll start with the graphical representation of data. Graphical representation of data. So first method to represent data graphically is bar graph. Now what is bar graph? Bar graph is actually a pictorial representation of numerical data by a number of bars. It means that with the help of bars, we actually represent numerical data into the pictorial form, and these bars are of uniform width with equal spacing between them. So it means, like suppose we'll take one example, like suppose if any let's say frequency distribution table is given, and we need to represent that data graphically or in the form of bar graph, then what we need to do? So accordingly, we'll first have to make the x and y axis. So always the horizontal line is taken as the x axis and the vertical line is taken as the y axis, and wherever these lines intersect each other, that point will be taken as 0 or the origin. So now accordingly what we need to do, like if suppose frequency distribution table is given, we need to represent it graphically. What we need to do, accordingly we need to make the this type of vertical bars. We need to make this type of vertical bars to represent the data graphically in the form of bar graph. In this way we represent the data graphically in the form of bar graph. And most important thing is, it is given that these bars should be of uniform width. It means that this width of the bar should be same throughout, and the spaces between these bars, it means these spaces that is taken, that is between the bars, should be same throughout. So this consistency should be maintained in making the bar graph. So that's why the bar graph is a pictorial representation. We'll write it, bar graph, it is a pictorial representation of numerical data by a number of bars of uniform width and with equal spacing between them. So it means uniform width means they were talking about this thing, that width of the bar should be same throughout with equal spacing between them. That is this thing they are talking about, that spaces should be same throughout between the bars. But it is not necessary that the width of the bar should be equal to the spaces between them. It is not necessary. But spaces between any two bars, any two consecutive bars, should be same throughout, and width of any bar that is taken in a particular graph should be same throughout in case of bar graph. So in this way we need to make the bar graph. So now we'll see one example. So accordingly we'll understand how to make the bar graph. So in this example, first we'll write down the example. So accordingly we'll understand what is said in the example, and then we'll make the bar graph. So here it is given academic year, and here it is given number of students. So academic year, like data is given as like 1996 to 97. Number of students are 50. So accordingly, between 97 to 98, academic year 97 to 98, number of students are 75. The same way 1998 to 99, number of students are 125. In the same way, from 1999 to 2000, number of students are 150 for the academic year, and then for the academic year 2000 to 2001, number of students are 200. So this is the data given, in which it is given that in the particular academic year how many students are there. So accordingly, we need to represent this data in the form of bar graph. What we need to do, first we'll take the x and y axis and the intersection point is origin. So see, it is not necessary always to make the vertical bars. If you want, you can make the horizontal bars also, but it is preferable to make the vertical bars because it sometimes looks good. So definitely, so that's why we'll take the vertical bars. And in drawing the vertical bars, whatever data is given, like in this particular example, data is given as academic year and number of students. So number of students is actually the frequency, you can say, and the academic year is you can say the class intervals are given here. So in this type of cases, so whenever this like class interval, or you can say the discrete data is given, let's say class marks, class intervals are given, or class marks are given, and according to that the frequencies are given. So if you need to make the vertical bars, so definitely in that case you need to represent class intervals or class marks onto the x-axis, and frequency or number of students should be taken on the y-axis. So then only we will get the vertical bars. Otherwise, if we have taken opposite, like if you have taken number of students on x-axis and academic year or class interval on y-axis, then we'll get the horizontal bars. There is no problem in taking the horizontal bars, but vertical bars is easier to analyze the problem, and it will sometimes look good also. So that's why we'll prefer vertical bars. So in this case, the academic year should be taken on x-axis, and accordingly number of students on y-axis. Now as academic year are given 1996 to 97, so accordingly we'll take one point and anywhere which will be taken as 96 to 97. Then accordingly next point is 97 to 98. Then next point is 98 to 99. Then accordingly next point is 99 to 2000. So in this way we'll make the graph, and on the y-axis we'll take the number of students, and this number of students which generally we have to divide it into the groups. Like suppose we have to accordingly plot the values on the y-axis. And so for plotting the values on the y-axis, it is necessary to analyze the problem. As you have seen, the number of students here are given as 50, 75, 125, 150, 200. So in this case, we'll take the gap of 50 here. So that is, first gap will be 0 to 50. Accordingly, next gap will be 50 to 100. Then next will be 100 to 150, and then next will be 150 to 200. It is very necessary to see this thing, that if you are taking the gap of 50 here, then this width or this size that is taken between 0 to 50 should be equal to the size that is taken from 50 to 100, and it is also equal to the size which is taken from 100 to 150, and then from 150 to 100 to 200. So this size should be same, because we are taking the same gap through on the y-axis. That's why we need to keep the size same. So for 96 to 97 there are 150 students. So accordingly we will make the bar for 96 97 up to 50. For 97 98 it is 75. So as we know that 75 will come between 50 to 100. So accordingly we'll see what will be the mid, where comes the mid value of 50 to 100. So accordingly we'll make the bar for 97 98 up to 75. Now accordingly for 98 to 99 it is 125, which comes between 100 to 150. So accordingly we will see where comes 125 will come between 100 to 150. So then accordingly we will make the bar for 98 to 99, and then for 99 to 2000 it is given as 150. So as we know 150 will come just above 125. So accordingly we will make the bar from 99 to 2000. So in this way we have to make the bars. So always keep in mind this thing, that bars width, that is this thing that I have taken throughout, is same. And also the spaces between the bars, that is this thing, spaces between the bars that I have taken throughout is also same. So this thing you need to keep in mind for representing the bar graph, that is for representing the numerical data into the form of bar graph, or for plotting the bar graph.